Hi, so today we're going through PAT paper from 2016, looking at question 19. Okay, so in question 19, we're told light of wavelength 625 nanometers shines onto a metal surface with work function 1 electron volt, and we're told electrons are emitted. In part A, we're asked to find what is the maximum speed of the emitted electrons. So this is clearly concerned with the photoelectric effect. And what the photoelectric effect says, if light of a particular frequency shines on a metal, then of particular metals, electrons will be emitted. And the frequency of that light has to correspond to an energy of the photons that is larger than a particular value of energy, which is called the work function. And what this says is that we know that HF, the energy of the incident light, the photons of light, is equal to phi, the work function, plus the maximum kinetic energy. And the reason it's the maximum kinetic energy is because phi, the work function, is defined to be the amount of energy that is required to remove the electron from the metal. So it has to do this much, phi much of the incident photon's energy must be used simply to remove it from the metal. And then the remaining energy is the kinetic energy. So this means that Emax plus phi gives us HF, or Emax equals to HF minus phi. So we can use this to find the maximum kinetic energy. So in our case, Emax is going to be equal to HF minus phi. So H, we were told, is Planck constant, which is 6 times 10 to the minus 34. Times the frequency. Well, that's 625 nanometers is the wavelength. And we know that C is F lambda. So F is going to equal C over lambda, the speed of light of lambda. So that's 3 times 10 to the 8 divided by lambda. Well, that's 625 times 10 to the minus 9. And it's this minus the work function. The work function we were given is 1 electron volt. And we know that 1 electron volt is 1.6 times 10 to the minus 19 joules. Okay, so let's try and simplify this. Well, we can say for the sake of argument that we can ignore the 2.5 here. So we'll say, to simplify it, so this is equal to 6.0 times 10 to the minus 34 divided by 6 times 10 to the minus 7 times 3 times 10 to the 8 minus 1.6 times 10 to the minus 19. Well, that's equal to 1 times 10 to the minus 21 times 3 times 10 to the 8. Well, that's 3 times 10, and the 8 added to the minus 21 gives us 8 minus 13. So that's minus 13 minus 1.6 times 10 to the minus 19. And well, the 1.6 times 10 to the minus 19 is absolutely minuscule compared to this. So we see the maximum kinetic energy that I have, E max, is going to be equal to 3 times 10 to the minus 13 joules. And well, we know that this corresponds to half mv squared, and therefore V max equals to this, and therefore V max is equal to, well, 6 times 10 to the minus 13 divided by the mass of an electron, which we're told is 1 times 10 to the minus 30 kilograms, all square rooted, and that corresponds to the square root of 6 times 10 to the minus 13 plus 30 to the 17, or, well, the square root of 6 is approximately 2.5, so it's approximately equal to 2.5 times 10 to the 8 meters per second. Okay, so part B asks us to find the maximum speed the electrons achieve when they're accelerated through a potential difference of 5 kilovolts. So we know that voltage is work done per coulomb of charge, and therefore work done is voltage times charge. Well, therefore, the change in energy, the gain in kinetic energy these electrons get, is going to be equal to the voltage, which is 5,000 volts, times their charge. Well, that's 1.6 times 10 to the minus 19. And that's equal to, well, 5 times 1.6 is 8, and then we have 5 times 10 to the 3, so that's 8 times 10 to the minus 16 joules. Well, therefore, the new kinetic energy they have is equal to 8 times 10 to the minus 16 joules plus 3 times 10 to the minus 13 joules. Well, let's come over here. So we have the new kinetic energy is equal to 8 times 10 to the minus 16 plus 3 times 10 to the minus 13. And so that's equal to 1/2 times mv squared. And we know m is 1 times 10 to the minus 30 times v squared. And therefore v squared is equal to 16 times 2, to 8 times 2 is 16, so that's 1.6 times 10 to the minus 15 plus 6 times 10 to the minus 13 divided by the mass, 1 times 10 to the minus 30, and that's equal to, well, 1.6 times 10 to the 15 plus 6 times 10 to the 17, and that is equal to, well, this is 0.016 times 10 to the 17 plus 6 times 10 to the 17, which comes out as 6.016 times 10 to the 17, and therefore its velocity is equal to the square root of 6 times 0.16 times 10 to the 17 meters per second.